Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
In this example here, we're dealing with two functions that we are very familiar with, a parabola and a linear function. And again, we're asked to find the area of the region enclosed by them. Now, this is a typical question that could show up in a way where we don't have access to technology to help us, but realistically, we don't need it. We can use all the skills we've been working towards to get to this point. This is a concave down parabola centered at 2, where the vertex at 2. Next, we're going to look at this line, y equals negative x. Now that is just the identity function reflected over the y-axis. Now you can see it wants the area of the region enclosed by these. So when it wants the area enclosed, what it's referring to is where these points meet, it's creating an area that is trapped between those two. Notice it didn't give us any bounds of integration. We need to find those. This is where our knowledge and understanding of systems comes into play. Where two functions equal each other, graphically they intersect. So to find these points of intersection, we're going to take this function, set it equal to this function, and we're going to solve. Now we can see we should get two answers. Based on our sketch, it appears possibly this number is going to be less than negative root 2 over 2, or root 2, excuse me. This number could be more than radical 2, but again, it's just a sketch. So right now I'm going to do some scratch work to figure out what these points of intersections are. Alright, so now I know it's 2 and negative 1. So what this means is this is at negative 1 and this point is at positive 2. Now I know my bounds of integration. Now I have to figure out what's my f of x, what's my g of x. Now notice in this particular case that part of the function is above the x-axis, part of it's below the x-axis. Remember, our formula will still work. So I'm going to draw a rectangle here with respect to the x-axis, and I can see the upper function, the upper bound, is going to be the parabola. If I draw the rest of the rectangle here, I can see that the lower bound is going to be the line. So now I'm ready to put them together. Now, as you can see here, when you do this, it's important to make sure that you're properly applying the negatives there. You notice I just caught myself, I missed a negative. So it's the f of x function minus the g of x function. It's a good idea to use grouping symbols when you do this to ensure you're not missing any terms or signs. At this point, this is a pretty doable integral. We could use reverse power rule and do all of this, but for simplicity's sake, we're going to use our calculator. If you were to calculate this by hand, you'd get 9 over 2. Or if you put it in your calculator, you would get a decimal of 4.5. So that's what this area between these two curves are.